All right, well, in this video, we're going to be looking at the second part of lesson 1.4, which brings us to this idea of a series. Now, an arithmetic series is basically just the sum of an arithmetic sequence. So, like if I have the arithmetic sequence we see here in the box, 5, 7, 9, 11, 13, 15, we see that it is arithmetic because we're adding 2 each time. Now, if I wanted to find the sum of that series by adding together all of those terms, yes, you might think, well, wouldn't it just be easier to use this formula or not to use the formula, just add them all up on our calculator? Yeah, in this situation, that might be the case. But if I had 100 terms in the sequence, you are not going to want to use a calculator. So you want to definitely be familiar with how to use this formula. So this formula, if you recognize, you might recognize some of the letters that we see here from when we talked about sequences. So n refers to the number of terms in the sequence. So in this scenario, we have a total of 1, 2, 3, 4, 5, 6. So there's 6 terms in that sequence, or 6 terms in the series that we're trying to find the sum of. And a sub 1 and a sub n refer to the first and the values of the first and last term. So the first term is 5, the last term is 15, and it's always going to be divided by 2. That's never going to change. So if we think of this as 6 times 20 divided by 2, now there's a couple ways you could do this in your head. You could take 6 times 20 and get 120 and recognize that the half of that would be 60. Or you could take 6 divided by 2 and get 3, multiply 3 times 20 and get 60. Or take half of 20 is 10 and multiply that times 6 and get 60. So you can see that there's a few different choices, a few different ways that you could do this in your head without having to pull out a calculator. But that's the formula. That's the only formula that we need to worry about right now. So again, with this one here, what is the sum of the terms of this arithmetic sequence? So we have 1, 4, 7, 10, and 13. Double check. Yes, it is an arithmetic sequence because we're adding 3 each time. So we're going to use that formula. So we're going to use the formula where first off we have 5 terms. So I'm going to say the sum of that series is we have 5 times the first term is 1, the last term is 13. We're all going to always divide that by 2. Now, yes, we can do that sum in our head, 1 plus 13, very easily. I like to show my work, so in that way you can see where the 14 came from by adding together the first and last terms. So now I can't take 5 times 2, I could take 5 divided by 2, but I'm going to get a decimal. So I'm going to do in my head, I'm going to take half of 14 is 7, and 5 times 7 is 35. So the sum of that series is 35. Now, another reason why we need to know that formula is because sometimes we're going to have problems like this one, where they tell us that there's 10 terms with a first term of 3 and a 10th term of 35. That's all they give me. They don't tell me what we're adding each time. They just tell me that it is, in fact, an arithmetic sequence. So the only way to solve this one is by using that formula. So again, there's 10 terms in the sequence, so n is 10. The first term is 3, and the 10th term is 35. So when I plug those values in, we would have 3 plus 35, again, divided by 2. Or 3 plus 35 is obviously 38. Now, 10 divided by 2 is 5, and you might not know what 5 times 38 would be. So this is one where, again, I would take half of 38. Maybe you recognize that half of 38 is 19. And 10 times 19 would be 190. Otherwise, you will have a calculator handy that you can also use. All right, I want you guys to go ahead and try these next two on your own. So I want you to hit pause and then hit play when you're ready to check to see if you've done these two correctly. All right, let's see how you did. Now, whether or not you identify these different parts like this or not is fine, but I'm going to do it over here. So we could see that n is 7. If we add up 1, 2, 3, 4, 5, 6, sure enough, there's 7 terms in that sequence, where the first term is 5 and the last term is 41. So plug those into your formulas. We'd have 7 times first term plus the last term, all divided by 2. Or 41 plus 5 is 46, all divided by 2. Now this is one you'd probably want to use your calculator, because I don't know that you'd want to do 23 times 7 in your head, but you should have got 161 would be the sum of those terms. And the next one We know that there's 12 terms, with the first term of 3 and a 12th term of 25, or 12 times 28 divided by 2. And when you do that, you end up getting 168 as your answer. So that's how you'd use the formula to find the sum of a series. Now, the other thing you need to be familiar with is this idea of sigma notation. Now, it's also called summation notation. So that's another word that might be thrown around. So if on Savas, if it says written in summation notation, that's what they mean. Summation notation, sigma notation means the same. Now, what do all these symbols mean? This Greek letter represents the sum. That's what that represents. Now, below there we have what's called the index. So the index tells us what term we're starting with. So this means we're going to start with the first term. The top tells us the ending term. So the ending term is not the value of the ending term, but it would say, if it was an 8 up there, that means that we would go up to the 8th term. Now off to the right here, this is always going to be an explicit formula. We're going to use that to find the values of the different terms. Okay, so the explicit formula is going to be off to the right, and we're going to use that to find the values for the needed terms. All right, let's look at this first example. So this is asking us to find the sum from the first term to the 9th term. Now the sum from the first term to the 9th term means that there's a total of 9 terms. Now we need to figure out, well, what's the value of our first and last term? Because in order to use this formula for a series, we need to know how many terms there are and what the first term and what the last term are. So let's find the first term. Find the first term, we're just going to put 1 in for I. That's our input. So 2 times 1, or 2, minus 6 gives us negative 4. So then to find the last term, that's the 9th term, we're going to put 9 in for I. So we're going to put that in our explicit formula. So 2 times 9 is 18. 18 minus 6 is 12. So our first term is negative 4, our last term is 12, and there's a total of 9 terms. So to find the sum of that series, we're going to use that formula that we were using up above. So negative 4 plus 12 is 8. And 9 times 8 is 72, divided by 2 is 36. All right, I want you guys to pause this video, and I want you to try this next one on your own, where we are finding the sum from the first term to the 13th term using that explicit formula, 3i plus 2. So hit pause, and then click on play when you're ready to check to see if you've done it correctly. All right, let's see what you did here. So the first term, I'm sorry, not the first term, the total number of terms is 13. So we're starting with the first term, we're ending with the 13th term. Now you might ask, is it always going to be whatever this is? And the answer to that is no. Because let's say if it said to start with the 5th term, well, then we'd have to take and figure out, well, how many terms is that from the 5th term to the 13th term by subtracting 13 and 5. Or actually, we would start with 5, so we'd actually count. So we'd have, so it's a little bit more trickier, but so don't worry about that. Always look, though, to see that this is starting with the first term. All right, let's look to see how to find the value of the first term and the value of the 13th term. So we take and put 1 in for I, so 3 times 1 is 3, plus 2 is 5. Find the value of the 13th term. We put 13 in for I. So 3 times 13 would be 39 plus 2 is 41. Now we're going to plug those into the formula. If 13 times the quantity 5 plus 41, all divided by 2, or 13 times 46 divided by 2. I expect that you would probably use your calculator for this. And when you do that, you end up getting your answer is 299. All right, let's look at these last two now. For these last two, they give us something different. So they want us to write this in sigma notation. And what they do is they give us that this series starts with 2 and then goes to 9 and 16 and so on until it ends at 79. Now, they don't tell us, again, we don't know what the, well, the one thing that we're missing is we don't know the number of terms in the series. So let's figure out what we're trying to find and what we do know. So I'm going to start with my sigma notation. So to get this in sigma notation, we're going to start with this Greek letter sigma. And then down here, we can just write that we're going to start with our first term. But again, what I don't know is I don't know how many terms there are, and I don't know the explicit formula. So those are the two pieces I need to figure out in order to get this in sigma notation. So let's start with the explicit formula. Now remember the explicit formula, we use this formula. A sub n equals our common difference times n minus 1 plus my first term. And let's plug in what we know into this formula. So we know that the common difference going from one term to the next is 7. And I don't know what n is yet. And then our first term we see is 2. Now I'm going to go ahead and simplify this by distributing the 7 through. And then combine like terms, and I get this, the expression 7n minus 5. So there's our explicit formula. All right, now the next thing I want to do is I want to figure out, well, what's n? What's going to go into how many terms are there in this series? Well, remember this represents the last term, or a sub n. So what I'm going to do is I'm going to substitute that in to here, into our a sub n for our explicit formula. So in other words, I can say that 79 equals 7 times n minus 5. And now if I solve this, I would add 5 to both sides and get 84 equals 7n. And now I would just divide both sides by 7, and I get that n equals 12. And you could do that on your calculator if you didn't know that. And that's how we get how many terms there would be in the series, which would be the top part of sigma notation. That's your answer. All right, so I know that there's a lot to that problem, so if you need to pause this video and then maybe go back to the start of this, just this example to kind of replay and kind of let this sink in, I would encourage you to do that. Otherwise, if you're feeling confident, why don't you guys go ahead and try this next one where you're going to do the same exact process for this other series. So if that's the case, pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so let's see how you did. So the first thing I'm going to do is I'm going to get this into sigma notation. By the way, just writing this out reminds me of one minor detail. Technically, going back to this previous one, since we're using I to represent our index, for our explicit formula, we want to know where to plug in I, not in for n. So whatever variable we have here, that's the same variable we would use there. Just a minor detail. I would never take points off on a test, but sometimes in your assignment on Savas, they might take off points for that. All right, so this is what we know though. So we're trying to find, just like before, we're trying to find our explicit formula and our number of terms in the series. So to find the explicit formula, let's use that formula. So we know our common difference in this case is 5. And we know our first term is 8. So when I go to solve this, I would distribute the 5 through. Get 5n minus 5 plus 8, combine like terms. Negative 5 plus 8 is 3. So now we have our explicit formula. So hopefully you're able to get that. Next, let's figure out what n is, the number of terms there are. And we know that their last term is 43, so we're going to put that in for a sub n. When I solve this, I would subtract 3 to get 40. Divide by 5, and I get 8. So there's 8 terms in the series. So that would be your answer for that final one. So hopefully that made sense to you. And with that, that is the end of lesson 1-4B here. So good luck as you work on your assignment.